Welcome to myprojectbazaar.com. Our product title is New Inverter Control for Balancing Standalone Microgrid Base Voltage, a review on MG power quality. Let us sort out abstract. A standalone microgrid suffers from high voltage unbalancing due to both single base and unbalanced loads. This design presents a comprehensive survey about the available techniques and controllers or MG power quality improvement. Recently, trends and schemes for the standalone MG power quality improvement are reported in detail. The techniques which concern with the MG voltage unbalancing issue are highlighted. In addition, this design develops a simple schemes for balancing the MG basis voltage. The proposed scheme employs a new interfacing inverter topology and control. The three-ways compact unit interfacing inverter of the distributed generator has been result in form of three single base inverter units. Each single base inverter unit is controlled independently to achieve MG base voltage balancing. At different load operating conditions, the three single base inverter units runs at different values and types power factors. Employing the proposed inverter control achieves perfect base voltages balancing at the most MG buses. Before employing the proposed inverter control, the voltage unbalancing ratio at some buses exceeds than 60%. This ratio approximately sinks to zero after including the proposed inverter control. The performance of the proposed inverter control has been tested under different load conditions. In addition, the performance of the proposed inverter control is compared with both the old inverter control and the conventional inverter control. Only a symbol to the old converter control is sufficient to implement the new inverter control. The proposed inverter control is very simple and highly economical, attractive, and also in this process only did for the client requirement flow, so only did for the flow diagram basis, and also corresponding output only here we provide. Next we see about the flow diagram of our product. In this flow diagram, the inverter topology only changing, but the inverter processing is also same. The input is DC, output is AC. So the conversion process is same, but the topology only different. And also the switches are triggered by using of the PWM generator. And the input source is a PV panel, so wind turbine and PV panel. So wind turbine we using that wind turbine is converted into DC using of diode rectifier. After that, that is fed into the inverter section, and also PV panel is provide the DC supply. So that DC supply is further boosted using of DC to DC boost converter. Then that is fed into the inverter section. In the inverter section, both two kind of sources is fed into the inverter section. In that inverter section is convert the AC for given PWM signals from the PWM generator, and that output of the inverter is fed into the microgrid. Generally the microgrid is parallelly run with the main grid. So when the main grid is supplied is demand, then the microgrid is supplied to that corresponding loads. And also the first type is caused by the operating conditions of the MGTGs, power output fluctuating of the renewable sources like wind turbine and PV. The second type is the voltage and current harmonics of the TGs, power electronic interfacing inverter. Also the current and the voltage harmonics may be generated by existence of the nonlinear loads. In the MG, the third type is maintaining of the MG stability during and subsequent fault occurrence. The fourth type of the MG power quality issue in the MG base voltage unbalancing existing of the single base loads and unbalanced three base loads. In the MG orienteds, the voltage unbalancing problem is occur. In the literature, several publications discussed and investigated the first three types. This design concern with the fourth type MG base voltage unbalancing the problem. In this proposed implementation, developed a new inverter configuration and control for reducing and mitigating the standalone MG base voltage unbalance. Next we see about the running process of our product. In this proposed implementation is done in MATLAB simulating environment. First open the MATLAB main window. After that we create a new model file. After creating that new model file, we arranging the elements from simulating library browser. In the simulating library browser mainly we use two kind of toolboxes. One is Sim Power System toolbox, another one commonly used toolbox. From those toolbox we getting the elements and then arranging that elements as per the given flow diagram. Then we assign the parameters. After that we connect the scope from the commonly used flux in across the measurement devices. After that we click the run icon, then the simulation will start to run. After when the simulation is entered, then open the scope, corresponding output will be shown. So first one is the IV curve. In this overall simulation is only done for 0.005 seconds. So because of our system RAM condition, so we only run for 0.005 seconds only. So this is the IV curve. This plotted between current and voltage in the solar panel. This is also PV panel. PV curve is drop between the power and voltage in the solar panel, and this is the solar output. First one is the power and next one is the current and another one is the voltage, and this is the corresponding output trigger waveforms, and this is the output inverter output voltage waveform VA, VB and VC, and this is also current waveform IA, IB and IC. Also this is the power, current and voltage for the another solar panel voltage, and these also those power, current, voltage for solar panel. So totally various kinds of sources used in this overall implementation, and also corresponding battery supercapacitors also used. So in this implementation we did as per the flow, and also they did only the corresponding implementation. Thank you for watching this video.